Okay, so we want to solve number 64, which is log base b of the fifth root of b squared is x. Okay, so I might think about that. Yeah, let's try it with the b's. Okay, so one option is that I could apply the same technique I've been doing, which is to say, okay, can I get rid of the b's? Well, the log anyway. How do I get rid of the log? Yeah, I say, okay, I gotta raise this thing to above a b, right? So I got b to the log base b of the fifth root of b squared, and that's x, right? Oh wait, what did I screw up? I gotta do the same thing to both sides of the equation, right? So it'd be b to the x. Yeah, I think this maybe wasn't the greatest idea, but we can do it anyway. So now what? The b and the log b cancel, right? So I've got the fifth root of b squared is b to the x. Oh yeah, I should change the fifth root of b squared to b to the 2/5. That's b to the x. So what? Because it's the fifth root, right, which is the 1/5 power. So this is b squared to the 1/5, and I multiply the exponents. You guys cool with that? So I got b to the 2/5 is b to the x. Now what can I do? We want to get rid of the b's, right? So we can't divide them out of there because they're the bases of exponents, right? That'll just subtract 1 from the exponents. That's not what I want. So I could...
Divide the exponents?
How did I get rid of log base b's? I raised both sides to the b, right? If I've got both sides raised to a b, I could do the other thing. I could log base b both sides. Yeah, if I log base b both sides. So I'm log base b'ing both sides. I'm going to get log base b, b of b to the 2/5. That's log base b of x, of b to the x, right? It's getting a little hasty. Yeah. So we take this, we log base b both sides, and we get log b of b to the 2/5 is log base b of b to the x, which seems more ridiculous, right? Except that the log b's and the b's cancel. So I get 2/5 is x. You guys see that? This was kind of a wander, right? I could have instead started at the beginning. I've got log base b of the fifth root of b squared, and that's x. At the beginning, I could have noticed this thing about b to the fifth root of b squared fifth root is b to the 2/5. If I noticed that here, I'd have log base b of b to the 2/5 is x. These will cancel, and I'll get 2/5 is x. Yeah, so what was up with the other way? I paid a price for not noticing this thing about fractions. You guys see that? We're much more likely to make an error there. The other thing I could have done that would have made my life a little easier is when I got to this point, instead of log base b'ing both sides, I really could have said, okay, this is counting how many b's there are, right? So this number and this number better be the same. Right? Surprise, surprise, that's the same thing I get when I log both sides. But that's really just because logs are asking, what about the exponent, right?
Do you skip that last step then?
Yeah, we could really skip the idea of logging both sides and just say 2 to the 5th has to be x, or sorry, 2/5 has to be x.
Would you get that on a test if we did
Yeah, yeah, I would understand if you got here. I would like you to do this, circle the exponents, little arrow between them or something, just to let me know what you're thinking. What's up?
Will there be an inverse function
On the test?
of this thing?
Oh, of this thing. Yeah, the inverse function of this thing is maybe weird. So, what do I mean by an inverse function? Well, usually I mean that there were some x's on the left-hand side, right? This thing's not a function of x.
It can be a function of b.
Yeah, we could write it as a function of b, in which case it really simplifies to b to the 2/5 power, right? Oh, wait, no it doesn't. So it's log base b of b to the 2/5 power, right? Which is the same thing as 2/5. So if I was going to write this as a function of b, right? F of b would just be 2 to the 2/5, which is not a very interesting function of b, right? This is like x equals 3. Or sorry, y equals 3, maybe. This is a horizontal line. You guys cool with that? This thing doesn't have an inverse function, right? Because it doesn't pass the horizontal line test. Cool.